Welcome back. You ready to do some multiplication? We are finishing up the video for lesson 12.4 on the product and the quotient rule. And we had just gotten this far where we had taken this derivative of this product of these two functions here that you see at the top of the screen. And now we are getting ready to distribute and multiply this out. So when you do that, it's whatever your choice is. I'm going to take this 5x to the fourth and distribute it to all three of those, and then I will do the same thing with the 26x, and I will be lining them up appropriately with the like terms. Let's see. This would be 35x to the seventh. This would be negative 25x to the sixth. 5 times 18 is going to give me 90, so that's going to be 90x to the fourth. Now multiply by the 26x. 26 times 7, 182, and it would be x to the fourth, so I'm going to write it underneath this x to the fourth. 182x to the fourth. 26x times negative 5x squared is going to be a negative 130x cubed. And then 26 times 18, that one I had to do on the calculator, 468, and I've got 1x. All right, now that's all one term, right? Plus. This we can go ahead and FOIL distribute like you would normally think of, because this is two binomials. Here we go. This is going to give me 21x squared, and x to the fifth is 7. The next term, that's the first, outside would give me 21 times 13. So that is a 273 x to the fourth. Inside is going to be negative 10x to the sixth. And the last term would be a negative 130x cubed. Boy, I barely made it. There we go. Now we need to combine terms, clean this up. See what fun this is? The only thing here that combined really was the x to the fourth, and that gave me 272x to the fourth. And then everything else is, nothing else I can combine yet between the two. So let's go ahead and, I'll just go ahead and quickly write this out. 6, that's 35x to the seventh. 130x cubed, 468x, 21x to the seventh, 273x to the fourth. All right, let's clean this up. Let's start with the big ones. To the seventh and to the seventh, both positive, so that's going to be 56x to the seventh. Okay, they're gone. Sixth. Here we go. Negative 25 and negative 10 is going to give me a negative 35. X to the sixth. Any fifth? No. Fourth. 272 plus 273. All right, that's going to give me 545x to the fourth. They're gone. Negative 130 minus 130, that one's easy, negative 260 x cubed. And our last but not least, 468x. Ta-da! Okay, that is the last combination of like terms. We are done. We found the derivative. Now, just for grins, when you're doing your homework, you're going to do it this way. But just for grins, let's take this part of the problem where we wrote the two functions that we were going to multiply. So I'm just going to take this and I'm going to come down here. If I do that and I take the derivative of that product, so I'm going to go ahead and FOIL that out. You ready? So x to the 5th times 7x to the 3rd gives me 7x to the 8th. So this is, I'm still taking the derivative. I haven't taken the derivative yet. All I'm doing is taking the product right now. And then x to the 5th times negative 5, that would be negative 5x to the 7th. X to the 5th times 18 would be plus 18x to the 5th. Now multiply by the 13. 13 times 7 is 91. That would be x to the 5th. So I'm going to write that underneath that x to the 5th. 13 times 5, 65. That's a negative 65x to the 4th. 13 times 18 is 234x squared. Yes. Now, when I combine those, all right, this right here, I combine that, that's going to give me 109x to the 5th. And then you simply take the derivative of each one of those. So that's going to be 8 times 7, which is 56x to the 7th. This is a negative 35x, reduce the exponent. This would be 5 times 109. That would give, and it's positive, so it's 545x, reduce it by 1, 4. 4 times negative 65 is going to be 260x, reduce that by 1. 2 times 234, it's positive. 468, reduce the power by 1. We just found the derivative. Oh my goodness, look at there. It's the exact same thing. And you decide which one you'd like. I know this one's a little easier. And as I said, when you're given the option, you can do this most of the time. But sometimes you're going to have to practice and know that product rule, especially when you have trigonometry in your functions, sine, cosine, tangent, whatever you have. And then that changes everything quite a bit. All right, now we're going to talk about something called the quotient rule. Quotient rule is a little bit different. So if you have, I'm going to go to a brand new piece of paper that doesn't have stuff bleeding through. Here we go. So if you have a function, we'll call it h, where you have f in the numerator and g in the denominator, then you can apply what's called the quotient rule. Now the quotient rule, there's not a shortcut around it. You really need to do this every time. And a little trick that your calculus teacher next year, or possibly Ms. Doyle taught me, is you take the bottom function and you square that immediately. All right, so we're going to have g of x squared. That goes in the denominator so you don't forget it. Then the numerator looks very similar to our product rule. We're going to take the derivative of f, and we're going to have times function g. We're going to have the derivative of g, and we're going to multiply by the function of f. But here's the kicker. This one is subtracted, and that's different because the product rule is the sum. So if you'll remember that the quotient rule has that subtraction sign, that will make it much easier for you to remember. All right, quotient rule. Here we go. And that's used, you apply the quotient rule to get the derivative of h. Let's do an example. What is this example? This is example 5. If we have function h that is x squared plus 8 divided by x cubed minus 2, and I want you to find the derivative of h. All right, so we're going to let this be function f, and we're going to let this be function g. When you find the derivative, we are going to apply this quotient rule. Ready? So we're going to take the g function, and we're going to put it in the denominator, and we're going to square it. X cubed minus 2 squared. And very often you leave that. You're not going to FOIL multiply that out and combine terms. The majority of the problems I saw just left that alone. There's no need unless there's a nice way to simplify it. But for the most part, you're just going to leave the denominator alone. All right, let's go back to the numerator. The first term is the derivative of function f. So the derivative of the numerator here is simply 2x. We're going to multiply that by g, function g. So x cubed minus 2. We subtract, and now we take the derivative of the denominator, which is, 3x squared? And we're going to multiply that by function f, which is x squared plus 8. Okay, I'm going to scoot this up because now we have the derivative. Now we have the hard part done. We've remembered the formula. We've got the derivatives done. Now we get to play with the algebra. Okay, we're going to distribute the numerator and combine like terms. So 2x times x cubed is 2x to the 4th. 2x times a negative 2 is negative 4x minus. Now I'm going to put this in parentheses just to remind us that we may need to distribute that negative. So this becomes 3x to the 4th, and this is 24x squared. All still over x cubed minus 2 squared. Now I do want you to remember that that negative distributes, and as I said, if you wanted to do that first when you were writing it down, that's fine. I just don't want you to forget it. Now let's combine. We have a 2x to the 4th minus 3x to the 4th. So I have negative x to the 4th. I have an x squared here, but it's negative 24x squared. And then I'm left with negative 4x. All over x cubed minus 2 squared. You say, Ms. Reeves, we could factor out an x in the numerator. Yes, I'm aware you can, but you don't need to. It's not going to benefit you. Yes, it would look nice and you could factor it out, but it doesn't reduce with anything in the denominator, so it's a waste of, sort of like a waste of time. You don't need to do that. Okay? Just for grins, let's quickly do one more. And so you have example 6. We're going to play with function j. We're going to have 7x minus 10 over 12x plus 5. And I'd like you to find the derivative of function j. All right, here we go. The derivative is going to be all over this 12x plus 5 squared, right? Do that first, you don't forget it. Now go back up, take the derivative of the numerator, which is 7, times our denominator, which is 12x plus 5. Whoops, almost lost my x there. Minus the derivative of the denominator, which is 12, times function f, or the numerator, which is 7x minus 10. Now you've done the derivative, and now you are cleaning up the algebra. So you have 7 times 12x So you're going to have 84x plus 35 minus, I'm going to combine it this time, that would be a negative 84x, and that would be a positive 120. Well, look what happens. What do you see that's going to cancel? These are gone. All right, and you're left with 35 plus 120. That's why it's real important that you have that sign correct. So you have 155 over your denominator of 12x plus 5 squared, and you're done. Okay? So when you come to class, we will practice a few of these together, and I look forward to seeing you then. Thank you.